We're going to take a look at polyatomic ions in this lesson, and polyatomic ions is exactly what it sounds like. Poly means many or more than one, atomic, so more than one atom acting as a single ion. These are not super complicated, but they do have different names, and there's a parenthesis that we use when we're writing chemical formulas with them. So, a group of covalently bonded atoms that acts as a single ion. Now let's think about what that means. Okay, a great example of this is ammonium. Ammonium is an NH4 that has a 1 plus charge. Let's think about what that actually is. Nitrogen, if you remember, has 1, 2, 3, 4, 5 valence electrons. Hydrogen has 1. So hydrogen can form a covalent bond here, hydrogen can form a covalent bond here, hydrogen can form a covalent bond here. That's NH3. You'll notice ammonium is NH4 with a 1 plus charge. So if I have another hydrogen over here with its valence electron, it can give that electron away, and then it can come hang out here and share these two electrons with nitrogen. But that means this is a positive charged hydrogen now. But since these are all sharing electrons, what we actually end up with is hydrogen with a single bond to nitrogen, single bond to hydrogen, single bond to hydrogen, single bond to hydrogen, and then this whole thing has a positive 1 charge, or a 1 plus charge on it. This is a polyatomic ion. This happens to be a positive one. Many of these are anions. Many of them are negative. And we're not going to look at the structure of all of them, but that does kind of help to show you, okay, yeah, we can have covalent bonds between these things, but then we end up with a charge. Okay? When we have things like this, we have polyatomic ions. And there's a few of them that you are going to need to be able to recognize on site. You should just know what they are. The one we just looked at, you should know it. You should know its formula. You should know its charge. So NH4 with a 1 plus charge. Hydroxide, OH minus. Okay, so 1 oxygen, 1 hydrogen, and it's got a negative charge. Okay, and it's a 1 minus. Nitrate is NO3 with a 1 minus charge. Carbonate, CO3, and carbonate has a 2 minus charge. And then sulfate, SO4, with a 2 minus charge. And then finally, phosphate, which is PO4, and it has a 3 minus charge. Okay? So you treat each one of these things just like they're in ion. So in a chemical formula, you might see ammonium. Well, let's look at okay, ammonium hydroxide. Well, that one's a little bit weird. All right, let's look at something like lithium nitrate. Now you know lithium is a 1 plus ion. It's an alkali metal. It has 1 valence electron. It gives that away. It's a lithium 1 plus. So if I had lithium and nitrate, nitrate is NO3 minus. What I would end up with is LiNO3. But what happens if I had something like magnesium with nitrate? Magnesium is a 2 plus ion. It has 2 valence electrons. It gives them both away and ends up 2 plus. Well, we do exactly like we did before. Okay, NO3 is still a 1 minus ion. So if I look at this and I'm going to cross this over so that my charge is balanced, I need 1 magnesium but 2 NO3s. So when I need multiple polyatomic ions, I put the polyatomic ion in parentheses, and then I remember, oh, it's one thing, I have 2 nitrate ions. Okay? Alright, so compounds containing polyatomic ions, we use the similar rules as ionic compounds. The cation is first. The positive thing is always named first. The anion is second. However, you do not change the ending of a polyatomic ion. This is nitrate. We're going to call it nitrate. Carbonate, carbonate. NH4 is ammonium. We're not going to change any of that. So NH4 is ammonium. And if F is fluorine, but we still change the ending of fluorine, it's not a polyatomic ion, to IDE, so ammonium fluoride. Calcium, that didn't change, carbonate. And lithium nitrate. So these follow similar naming rules as before. Now, when you're going the other way, it's a little bit trickier. Determine the formula for these compounds. Alright, aluminum, Al, is a 3 plus ion. Sulfate, SO4, remember, sulfate is actually a 2 minus ion. So I've got to start with my ions, and then I'm going to cross them so that I can come up with the formula. So aluminum sulfate is Al2, SO4, That's in parentheses because it's a polyatomic ion, 3. Magnesium nitrate, magnesium's in group 2. It's got 2 valence electrons, so it's a 2 plus ion. Nitrate, NO3, is just a 1 minus, so I'm going to need 2 nitrates, 1 magnesium, so I'm going to have MgNO3 in parentheses. It's a polyatomic ion, 2. Okay, don't write those arrows when you're writing formulas. And then calcium phosphate. Calcium is also an alkaline earth metal. It's also a 2 plus ion. Phosphate, PO4, is a 3 minus ion. So I'm going to need 3 calciums. Right, I'm going to cross that, and I'm going to need 2 phosphate groups. So PO4, 2. Now, if you have an example where there's only one of your polyatomic ions, so like I had earlier, lithium nitrate, LiNO3, there's no parentheses here. If you want to write them just so you remember it's a polyatomic ion, that's okay. It's not conventional, but it's alright to help you remember it's a polyatomic ion. Now, not only do we have polyatomic ions, there's some things in the B group. Remember, in the periodic table you have the alkali metals in the first column, the alkaline earth metals in the second column, and then you have the 10 groups in the middle that we call the B group, or the transition metals, that we don't usually talk about. Well, that's because they do some different things. Some of them have multiple ions. They can be in 2 or 3 or 4 different charges. So we're going to look at a couple of those just so you can deal with them. And then, of course, the rest of the A group follows the rest of the rules. Alright, so if we have some B group elements that don't follow the conventional rules, we use these Roman numerals to identify them. That's 2, 3, 1, 2, 3, 4, right? So Roman numeral I is 1, II is 2, III is 3, IV is 4, V is 5, VI is 6. We probably won't see anything higher than that. Okay, so to identify these different ions, Roman numerals are used. So if we actually look at this, iron 2, what that means is that's iron, which has symbol Fe, with a 2 plus charge. Iron 3 means iron with a 3 plus charge. See, this is not hard. Copper 1, copper with a 1 plus charge. They are metals, so they will be cations. Copper 2, 2 plus charge. Titanium, 3 plus, and titanium, 4 plus. Chromium can also do this. There's a few other metals that have multiple ions. Now, when you're naming them, the numerals are written in the formula or in the name, but in the chemical formula, they're not written. So iron 3 oxide, I look at that. If I want the chemical formula, I'm going to start with iron 3, which is a 3 plus. Oxide tells me oxygen. Oxygen's a 2 minus ion, so I've got to do my charges. That 2 switches, that 3 switches, and I end up with Fe2O3. Okay. Iron 2 oxide, okay, so iron 2 is Fe2 plus, oxide is 2 minus, so those balance, 2 plus balances a 2 minus, so I have FeO. Okay, so there is a difference between iron 3 oxide and iron 2 oxide in the chemical formula, in the name, and even in the compound a little bit. These have different colors. One of them is more common than the other. Okay. Here I have iron hydroxide. Okay, you should recognize OH as a polyatomic ion. Remember, hydroxide has a 1 minus charge. So this is an interesting thing because I want the name, but since the formula doesn't tell me what the charge is, I kind of have to figure it out. Since I can uncross this essentially. I can go Fe, and so this must have come from up here, 3 plus. That tells me this is iron 3, and then OH is hydroxide. If I look at this one, I'm going to uncross it, and so I see iron 2. Much of an I. Iron 2 hydroxide. So these are not incredibly hard. You just have to pay attention to your charge and what's going on with that.